In many third-grade classrooms, mathematics is delivered through isolated, theoretical word problems. Because these scenarios exist only on a single page and carry no ongoing consequences, students often compute the answer, forget the context, and move on. To build actual mathematical fluency, we designed the Bakery. This is a 5-day decision mission built specifically for the Grade 3 math block. Operating in small teams, students take control of the fictional Harbor Street Bakery. They have to manage a persistent, ongoing economic model where the numbers from yesterday directly impact what they can afford today. Running the business forces them to continuously apply multiplication within 100, addition and subtraction within 1000, and two-step whole number equations. By placing their computations within a strict financial system, rote math problems become high-stakes tools for analyzing risk and planning production. This dashboard illustrates the exact mathematical constraints of the simulation. Students begin their operation with a baseline financial injection of a $50 bill, marked as their opening cash. They plan their production in units called batches. One single batch represents exactly 5 cupcakes. Next, they factor in the cost constraint. To bake that single batch, teams must spend exactly $6 from their cash reserve. On the upside, successfully selling those baked goods yields $2 in revenue for every individual cupcake. Finally, their operational capacity is strictly limited. Teams are capped at producing a maximum of 8 total batches per day. These intersecting numbers force students to run constant mental and physical checks to ensure they don't overspend the reserves and bankrupt the bakery. As these data points synthesize on screen, they form the daily requirement. Opening cash minus cost plus revenue equals closing cash. These rigid constraints guarantee that students have to master two-step equations just to survive the week. Traditional group work often suffers from a structural flaw. One confident student dominates the math while the rest of the group coasts. The simulation prevents this by dividing the cognitive load across 4 strict interdependent roles. First is the forecast reader. This student analyzes the expected demand ranges and identifies market uncertainties. They pass that data to the batch planner, who calculates the allowable batches and the total cupcakes the team will bake. The batch planner's numbers are handed to the cash checker. This role strictly executes the cost and revenue equations to ensure the plan is affordable. Finally, all data routes to the reason recorder. This student logs the team's ultimate choice and documents the specific evidence supporting it. Each of these roles mandates the use of specific sentence stems, requiring students to explicitly articulate their logic using phrases like, "the range says," or "our batches make." Because the workflow is a closed loop, teams cannot advance to the next day until all 4 nodes successfully synthesize their specific data point. This timeline maps the operational pacing. The simulation runs across 5 sessions, each lasting 35 to 45 minutes. On day 1, students have to formulate a baseline business plan before the actual demand limits are fully known.
To do this, they analyze a survey graph and a forecast range rather than relying on exact, guaranteed numbers. As the timeline advances to day 2, teams receive the exact sales results from their previous day's predictions. Now, they have to integrate the exact forecast numbers from day 2 with their previous day's results to adjust their production math. The exercise explicitly trains them to base these revisions on their written ledger data rather than trying to rely on memory. By the end of the second session, a clear cycle is established. Data guides the initial decision, the real-world consequence is revealed, and that new evidence informs revision. On day 3, we introduce dynamic disruption. As this chart shows, a sudden, massive spike in demand hits the market. This forces teams to step away from rote calculation and mathematically articulate the exact risks and benefits of altering their production limits. By day 4, the primary pressure shifts from daily survival to long-term financial projection. A solid floor is established. Students must ensure they retain a minimum of $72 on hand. Teams have to accurately calculate their projected closing cash to hit this exact threshold. This floor exists because day 5 brings a massive school order for 60 cupcakes. It costs $72 to bake, yields $120 in revenue, and generates a $48 profit margin. Placing this large financial requirement at the end of the week directly ties their daily computational accuracy to a highly visible, long-term objective. When implementing group simulations, administrators naturally ask how educators can accurately grade a highly unpredictable team outcome. There is a common assumption that if a team bankrupts their fictional bakery, the students have failed the math assignment. We designed a framework isolating the team's business outcome from individual assessment. The left screen shows a red financial ledger, strictly for student feedback. The right populates the true summative score, derived solely from a Day 5 individual written reflection. Educators score students on a 1 to 4 scale across 4 distinct dimensions: proof, thinking, growth, and teamwork. The evaluation focuses purely on the logic of their evidence and the accuracy of their math during revisions. A student can completely bankrupt the Harbor Street Bakery and still earn a perfect 16 out of 16 on their assessment, proving that rigorous mathematical reasoning matters more than a random game outcome. While the architecture of the mission is mathematically complex, the facilitation experience is highly streamlined for classroom educators. The entire 5-day package requires only about 20 minutes of first-use preparation. Included materials like the Teacher Confidence Guide act as a built-in safety net, providing exact facilitation moves to help teachers guide discussions when students miss an order or miscalculate. The simulation operates entirely on paper, requiring no hidden spreadsheets, external software links, or macros. To acquire the simulation materials and review the curriculum details, visit patienslearning.com. Your third graders will navigate the mathematics of risk by applying multiplication and 2-step equations to the concrete demands of their own bakery.